Everyone, today we're gonna discuss about the photoelectric effect, which is the very crucial experiment for the physics history. Here, the quantum nature of electromagnetic wave arises, and the classical theory of electromagnetic waves drop down. So, what is a photoelectric effect? When a high frequency electromagnetic waves drop on a photosensitive plate, then we observe current in that circuit, which is called photoelectric effect. Means electrons are emitting out because of the electromagnetic wave. When we go deep into the experimental study of the photoelectric effect, then we saw that it is not explainable by classical theory of radiation or classical theory of electromagnetic wave. So, in the first graph, the intensity versus photoelectric current graph is showing. So when we are increasing intensity of light, the photoelectric current is increasing. It is explainable classically because if we are increasing intensity, then then energy transferred to the metal is also increasing. So number of electrons are emitting more, so we get the more photoelectric current. In the second curve, here we have shown the stopping potential versus the intensity. So here we can see for different intensity, we are getting same stopping potential. Stopping potential is um, is the potential of this second sheet A, which is required to stop the electron. So it is directly telling the kinetic energy of the electrons. So according to these curves, the intensity, when we are changing intensity, the kinetic energy of electrons are not changing. It is not explainable classically, because if intensity is changing, then we giving more kinetic energy to the metal, so electrons should have more kinetic energy, so stopping potential should change. But here we can see that the stopping potential is not the function of intensity. In the third curve, we have shown the frequency of incident radiation versus stopping potential. So when we are increasing in frequency, then stopping potential is increasing, means kinetic energy is increasing. And also there exists a threshold frequency. Below that, the electrons are not emitting out. It is also not explainable classically, because classically, if even if the frequency is less than the threshold frequency, somehow some energy is transferring to the metal, so electrons should emit out, and we observe the current, so stopping potential should have some value. But here we can see that the below the frequency, there is no value of stopping potential. And so Einstein uses the Planck theory of electromagnetic radiation, or to explain these experimental results of the photoelectric effect, which tells that the energy transfer in an electromagnetic wave is done by the discrete packets of energy, which are called photons. So here we see the particle nature of the electromagnetic radiation. So, according to the Einstein's theory, when we are increasing intensity, the number of photons are increasing, and when we are increasing frequency, then energy of a photon is increasing. So, from this we can explain the above three curves. So, when we are increasing the intensity of lights, means we are increasing the number of photons. So, more number of photons hits more number of electrons, so they emit out, and we get the more photoelectric current. And here we see that stopping potential is not the function of intensity. So if we are increasing intensity, then only number of photons are increasing, so number of electrons in the photoelectric current is increasing, but their kinetic energy is not increasing, because kinetic energy should be dependent on frequency, because more energy will transfer to the electron via frequency, not by intensity. Intensity is only telling the number of photons. So stopping potential should not be the function of intensity. And in the third curve, it is directly visible that the stopping potential or kinetic energy is a direct function of incident radiation. So if in a photon we are increasing frequency, then its energy is high, so electrons are getting more kinetic energy, so more stopping potential is required to stop them. And so there exists a threshold frequency because electrons required a minimum amount of energy to leave the metal. So if the energy of the photon is below the work function, then stopping potential value is zero, means electrons doesn't have kinetic energy, they are not emitting out. And if the energy of the photon is high enough to overpower the work function, then they are getting kinetic energy, and we get the stopping value of the stopping potential. And also, according to the classical theory, there should be some time gap between incident of photon and detecting the current. But in experiments we show that we see that the photoelectric effect doesn't have any time gap. So according to classical theory, the energy transfer is continuous, so it should have some time. But according to quantum theory or Einstein theory, the energy transfer is discrete and instantaneous, so it should not have time gap. So it is the here we have the famous equation of Einstein, which tells that the energy of the photon is used by electron via two ways. One is to getting out of the metal, and second is to gaining the kinetic energy. Here h nu is the energy of the incident photon, w is the work function of metal, and half mv square is the maximum kinetic energy of the electrons. Einstein got also Nobel Prize for explaining these results. And thank you.